All right, here we are. We're going to talk about Chapter 7, 3, Period, Amplitude, and Phase Shifts.
Notice that these aren't really the titles that are in the book, but this is what we're giving you. So,
why are we just coming out of it now?
Oops, sorry. Didn't mean to do that. Ha! I meant to press that. Okay, so what we've talked about before is the period of a function is how long it takes for one cycle to occur. Now, the important thing about that is, up to this point, we've only dealt with the fact that sine and cosine and their reciprocals, cosecant and secant, take a period of 2 pi. We are now going to, in this lesson, we are going to change how long a period occurs by inserting one particular number in the equation, okay? So that's going to be where things get a little tricky. Now, as we discovered in the last section, our sine starts at a 0, stupid memory trick, and cosine starts at a max. Now, if we put a coefficient that is negative in front of sine, then it starts at a 0 and goes down. If we put a coefficient that is positive, it starts at a whoopsie, undo that. If we put a coefficient that is positive, it starts at a 0 and goes up. Same thing with cosine. If we start with a negative coefficient for cosine, then instead of starting at a maximum, you started at a minimum. You got that experience in the work you did on the rounds in the last class. Okay, well now we're going to talk about how to adjust the period of sine and cosine. If you see a number right here as the coefficient of your angle, then that is going to change how long your period is, how long it takes for one cycle to occur. So now we have another thing to figure out, and that is that the period is found by the absolute value of 2 pi, the standard length for sine and cosine, over b. Got it? Sine and cosine have a period of 2 pi and their reciprocals, cosecant and secant respectively. But when we have a coefficient in front of our angle, we now take the period of 2 pi and divide it by b, and that is how long that particular function is going to take to have one cycle occur. Now, we also learned in the lessons before today that critical points happen. We needed 4 points. We needed a starting point and 4 more points. And so what we told you is take the period and divide it by 4. Okay, now prior to making this adjustment in our equations, we just said it was pi over 2. Every increment on the axis had to happen pi over 2 units away. Okay, so now we really have to be more explicit and talk about period divide by 4. Okay? So first of all, let's look at how to work with an equation. So what is our b?
B is 4 because the coefficient of the angle is 4 inside my cosine.
So what does that make our period? Well, the period is the absolute value of 2 pi over b. So that makes it pi over 2. So this one means that is how long a whole cycle takes. So how often do we get critical points? Period, divide by 4. So that's really pi over 8. And now this is where things get tricky on the graph. All right, what we're going to do is look, one period is pi over 2. So the other thing is how many cycles occur. In the standard 2 pi interval, the 4 means you're going to get 4 cycles. Oopsie, can't spell. You're going to get 4 cycles in the standard 2 pi interval. So here's the question I have for you. Do we want to go all the way? Do we want this to be 2 pi to negative 2 pi? That's going to be crazy. If we make this all the way out here to 2 pi, I don't want to put 2 pi right here. So when you are graphing these, what we want to do is think about how long is it going to take for one cycle, and label that. Okay, this is our 2 pi. One cycle is pi over 2, and let's just for this one compare what happens in 2 pi. The standard cosine in 2 pi is going to happen like this. A maximum, 0, minimum, 0, maximum. This is not the graph I'm really interested in. but I'm going to show you how we want to think about it. That is the cosine of t. Now let's graph cosine of 4t. Okay, what did we say? Cosine of 4t says 1 period occurs in pi over 2. So what do we have to do here? We have to divide this part into 4 units. So this is pi over 2, making that pi over 4, and that halfway, pi over 8, and making this 3 pi over 8. You can see that when I go to graph this, it's going to look pretty awful. Okay, here, there's a 0, there's a minimum, there's a 0, and here we are back at a maximum. I think I'll use a different color to graph it. Now, in reality, we like to see generally 2 cycles, 2 complete cycles of the graph. So in the future, we probably wouldn't go ahead and go all the way to 2 pi on a graph like this, because how many cycles are we going to see in the 2 pi?
4.
We're going to see 4, okay? So to graph more of this, we would label each one of these hash marks. And by labeling, that's what? 3 pi over 8, 4 pi over 8. This is 5 pi over 8. 6 pi over 8 is what? 3 pi over 4? Is that
Yes.
right? 3 pi over 4. 7 pi over 8. 8 pi over 8. 9 pi over 8. You get the point. I don't want to label all of it because it'll take us too long on the video. But, oopsie, that's wrong. This should be a minimum. There's another cycle.
To avoid making mistakes on this, you really need to put a point for your minimums, maximums, and zeros so that you have somewhere that you're aiming for when you're trying to draw the curve.
Yeah, because what I just did wasn't good. Okay, that's a better one, sort of, except I didn't make it down there to that minimum. But you get the point, right? So now you see, look, 1, 2, 3, 4 complete cycles. So there's 2 things that we think about this. Number 1, that number tells you in the standard 2 pi interval how many cycles are going to occur, and then it changes how long it takes for 1 cycle to occur.
Okay, so for this one, we're going to graph a sine function. This has a coefficient of 1/2 in front of the angle, which means we're going to only go through 1/2 of a cycle in the standard 2 pi interval. So that's going to make our graph look a lot flatter, okay? The period is going to be 2 pi divided by 1/2, absolute value, which is 4 pi. So instead of going through 1 cycle in 2 pi, we're going through 1 cycle in 4 pi. The critical points are 4 pi divided by 4, which is pi. So each critical point is going to be given at 1 pi intervals. So in order to get 2 full cycles, how far do we have to go? All the way to 2 times the period, which is 8 pi. So in order for me to graph this effectively, I'm going to actually have to have all the way to 8 pi on my graph.
Yeah, and there are times, though, when it's easier for us to look at, instead of 2 full cycles, to look at, well, let's compare 1 cycle of this. So let's change something on this one. Usually we like, oh, you want to do 2 full cycles?
Okay,
Okay,
I'm going to
all
show
right.
you. Okay, so
Okay,
normally 1 cycle would go here, okay, and then, so now I'm going to have a cycle go all the way to here. So let's see, right here I have pi over 2. Here's pi over...
No, that's pi.
Pi, sorry.
When you're doing it on the screen and you're standing in front of one of your increments.
And then 3 pi over 2. And then I'm going to go ahead and, this is 3 pi, and this is 5 pi. All right. So now we have that all nicely.
And you want to do 7 pi over there too? Yeah. Yeah. Okay.
I think we'll get the idea. Okay. -1 and 1. So here's 1 and here's -1. And I'm going to erase my stuff so I don't have all of this there. Okay. So for standard, we have it every pi over 2, right? So that would be its sign. So we start at a 0, go to a maximum, 0, minimum, 0, maximum, 0, minimum, 0. And now I'm going to graph, this is my normal sine function. I know it looks skinnier, it's because my scale is much more squished.
Remember in the last class we told y'all it's really important that you pay attention to your scale, because while this looks like it's steeper, when you look at the fact that
this is all the way to 4 pi.
Right, and pi over 2 is about 1.57, so our scale on the horizontal axis is 1.57 for each hash mark, but our scale on the vertical axis is only 1, so it's not a square scale at all.
Okay, so now with my new function, sine of 1/2 t, I'm going to start at 0. My critical points are at every pi, so so this is a 0, the maximum is at pi, then at 2 pi I have another 0.
Now, sketch that real quick, Ms. Miller. Notice that what has happened in the standard interval of 2 pi. How much of the full cycle did we get?
Half of it.
And that's why this is important up here. That tells you in the standard 2 pi interval, we are only going to see 1/2 of the cycle.
Okay, and then...
So you have a couple of checkpoints on your to consider as you graph these. There are a couple of places you can find mistakes or prevent mistakes.
And then at 6 pi, and then here's 7 pi. All right, when you graph these, be sure not to make them look like V's, up and down, up and down. I know when they get skinnier, it's harder to do, but make sure that they're curved.
Good job.
Okay.
Okay, so now look at what we're graphing. We're not going to actually graph. We're just going to analyze. Okay, we're looking at secant, 8t. So our b is 8. So what's our period?
Period is the absolute value of 2 pi over 8, which is pi over 4.
So how often do critical points happen? Every pi over 4 divided by 4, so that's pi over 16. Can you imagine if we were to graph this, how crazy the x-axis or the horizontal axis would be? You know, it would be awesome. And remember, we're graphing secant, so we're actually not graphing cosine. We just use cosine as our guide. All right, let's look at the next one. Now, this kind of looks weird, but we could write this as cosecant of 1/2 t. All right, recognize that's the same thing. So what's our b?
1/2.
So what's our period?
Period is 2 pi divided by 1/2.
In absolute
value, which is 4 pi.
Yep, and critical points, this is an easy one to graph. 4 pi over 4, and so that happens every pi units.
Okay.
You will not find the information about how to find critical points in your textbook, so if you are not watching the videos, and this is to those of you who are, if people are not watching the videos, they miss out on really important stuff that the tutor that they go to isn't going to be able to help them. So, advice, watch the videos.
So tell them to watch the video. First problem, go ahead and graph this one right here.
Actually, we're just going to determine the period.
I'm sorry.
Yeah, we're just going to determine, because this one's kind of crazy to graph. Hey, but here's how much of the cycle would occur in one standard 2 pi? How much of the sine would we see? That's an interesting one.
Okay, and how often critical points occur?
Okay, so here we go. Now we actually are going to, remember the last class where we shifted up and down? That actually gets a letter in our equation. The letter it gets is D. So now we're going to do a little bit more analysis here. Our A is our coefficient. That's 2. What's that number going to do? Well, it is going to make our graph steeper, okay? Instead of our amplitude, the number instead of going 1 above and below our 0 axis, we're now going to go 2 units above and below our 0 axis, okay? Our B is 4. So our critical points would be...
our period would be...
Oh, yeah, I should have written that down.
Period is going to be 2 pi over 4.
In absolute value bars, because sometimes, guys, you get a negative number there. That's why the absolutes are there.
And remember, the negative would actually flip it across the y-axis.
Okay.
And then, so our critical points are going to happen every pi over 2 divided by 4, which is pi over 8.
Okay, so that's what I'm going to mark off on every increment on my axis is going to be marked off in units of pi over 8. And the D is?
The D is -1.
Which means we're going to go down 1. So, first thing is, let's graph our vertical shift. The order that we do things when you graph is the first thing you want to deal with the vertical shift.
Or horizontal shift. Or both at the same time.
Yeah, I don't have a horizontal shift in this one, so the next thing I'm going to deal with is put my amplitude marking on the vertical axis, and then I'm going to deal with marking off my critical points. Now, when we have a horizontal shift as well, I do the vertical shift first, then the horizontal, and then continue.
So always do your shifts first.
Yes. All right, and pay attention to the fact that we're going to go down 1, but I have to go 2 above and below that down. So I want to make sure on my axis here that I leave myself room. So here's my shift down, and I'm going to draw that dotted line in. Okay. Now I want to go 2 above it and 2 below. So I want to go down to -3 and up to 1. And it's important that you mark those on there. This isn't very visible. That's -1. Okay. Now the next thing is, let's see, we've taken care of that. Now we're going, and I've taken care of that, and now we're going to mark off our pi over 8s. So we want to see 2 cycles. How long is it going to take for 1 cycle to occur?
Pi over 2, because that's 1 period. So we need to at least graph to pi.
Okay, so we're going to graph to pi. So I'm going to come over here. We write our increments on the horizontal axis, not the 0 axis that gets shifted. So here's pi. Here's 2 pi. I am having...
No, that's pi over 2.
Oh, pi over 2. That's right. Oopsie. There you go. Thank you. Sorry. Pi over 2 for 1 cycle and pi for 2 cycles. And now we're going to divide pi over 2 into 4 more
pieces.
sections. So this will be pi over 4. Oh, I should probably write that one down below. Pi over 4. And then half of that is what? Pi over 8. 1 pi over 8, 2 pi over 8, 3 pi's over 8, 4 pi's over 8, 5 pi over 8, 6 pi over 8, which is 3 pi over 4, 3 pi over
8, 4, 4, 4. Yeah.
That's not right, because pi over 2.
No, it's half, 3/4, 1.
Oh, 1/2, duh.
It's early, guys. It's like 4, 7 a.m.
3 pi over 4, let's see, 5 pi over 8, 7 pi over 8, duh. Oh gosh, see, if we think about that sometimes, you can see that it's easy for anybody to make that mistake. Okay, so here we go, we're graphing cosine. So it starts at a max because we have a positive 2 as our leading coefficient. 0, minimum,
3.
0.
Oh,
look
0.
what I did!
Your 0 is not at 0. Your 0 is at the 0 axis, which is at -1.
Yep.
So you have to be really careful. So don't just willy-nilly start plotting points on the axis.
And to be honest, when I graph these, I like to do my starting and ending point, and then I like to go halfway between to graph the minimum, and then halfway between to graph the zeros so that I don't make that mistake. And there you go. Here is... Boom.
Now, one little thing about this, if you want to graph the parent function just to see what it looks like, graph the parent function shifted. Don't try to graph it from, the 0 and up and down, or from 1 to 0 to -1, because it's not going to look good. It's going to look a lot more effective, I guess. It would help you more if it was actually shifted down to the D, the -1, okay?
If we were to graph the parent function, I've only gone up to pi. So cosine would only have this part here. We would have started at a maximum, gone to a 0, and gone down to a minimum. And so you can really see how that number 4 right there really squished, because this is going to continue. If I were to continue, it's really the dotted line is the actual what the cosine would look like shifted down
1. All right, so let's look at what we have here. I'm going to rewrite this so that it's easier for me to find all of my nice values for A, B, and D. Okay, so this is -1/2 sine of 1/3 t plus 2. Now that plus 2 is not in the sign. If it was, there would be parentheses around it. So that means we're shifting up 2. Okay, so that's important. My axis is going to be shifted up 2. My A is -1/2.
Hey, what does that make the amplitude?
That makes the amplitude 1/2, because the amplitude is the absolute value of the coefficient. And
the amplitude the amplitude is a distance. Good.
So the negative means it's just going to flip it across the x-axis. The B is 1/3, which means the period is 2 pi divided by 1/3, which equals 6 pi.
Ooh. Well, on this one, because it's going to take 6 pi for one cycle to occur, we're going to graph only one full cycle, okay? So there are times when you'll just be asked to graph one cycle because otherwise it gets crazy on there.
So 6 pi, the critical points happen every period divided by 4. So that's 6 pi over 4, which is 3 pi over 2 is every critical point, which is actually, if you remember on the unit circle, that's like 270 degrees. So it's like
yeah, it's going to make our critical points. You have to think very carefully about our critical points here.
Okay, first we're going to graph our vertical shift. So that's up 2. And my amplitude here, I'm going to change this a little bit. My amplitude is -1/2. Okay, so I need to have 1/2 above and below my axes. Well, my amplitude is 1/2, so I need to go, okay, so this is 1, 2, and 3. So right here, this is 2, and I'm going to mark off 2.5 and 1.5. Okay, so it's going to be really skinny. Yeah.
Yeah, and that's actually, I changed the
Okay, so it's not there.
Yes,
okay,
exactly.
So I'm going to dot my axes here.
So the sinusoidal axis, our 0 axis, has been shifted up. So now, when we think about what that A is doing, the negative, we're not actually flipping it across the x-axis. We're graphing sine, so instead of starting at a 0 and going up on this shifted axis, we're going to start at a 0 and go down. It doesn't flip it across the regular x-axis. It's going to flip it across this dotted line, new 0 axis.
All right, so we've graphed that part. We've graphed the amplitude scale. So now we need to have the scale for the t-axis, which is going to be we need this 3 pi over 2. So I need to go to, we were going to go to 1 period, right? So 6 pi.
So every critical, yeah, so 6 pi. And so we know that halfway between has got to be 3 pi. Let's make it easy.
Remember, critical points happen at period over 4. So graph a period and then divide it into 4 sections.
So if this is 3 pi.
This is 3 pi over, freaking out. It's freaking out.
It's blinking, the light's blinking, you have to move like away from the, It's the blinking light of death. So while we're pausing here and waiting for the board to quit blinking, what Ms. Miller is saying is you want to go ahead and do the whole period and then mark them all off in units of 4 and then figure out what it needs to be. 3 pi over 2, 6 pi over 2, 9 pi over 2. And then that should end at 12 pi over 2, which is 6 pi. Yes, we can do some math.
Yay!
Okay, now let's remember, we're doing sine, and sine starts at a 0, usually goes to a maximum, but because of the negative coefficient, it's going to go to a minimum.
And the minimum's really squished small, okay? Because we're only going up and down 1/2.
Mm-hmm.
So then at 3 pi, we're going back to a 0. And then at 9 halves pi, we're going to go up to 2.5. And then at 6 pi, we're going to go back to a 0. So this is going to be really flat.
Shallow waves, like I was talking about in my class. In this case, because our A is 1/2, we have Galveston waves and not Alaska waves.
There.
Yeah. And then recognize that this does continue on. You know, these are continuous graphs, so we always want to recognize that they're going to continue.
Yeah.
Good. Okay, now we get to actually the most difficult part of this section. We've talked about that coefficient B. And in the last problem, you can see that what Ms. Miller did here is rewrote the function with that 1/3. And now what happens is when we have a number added to or subtracted from this, we need to bring the 1/3 out. So if we look here, we know that when there is a number inside, we have a horizontal shift, and whatever would make that quantity 0 is the direction of the shift. Well, let's look at our combined all the whistles and bells equation now. Here's our A, we know what that does. Here's our D, we know what that does. Here's our C, we know what that does. But notice that now that B has to be factored out. For B to work well, it has to be factored out. Now, this is another place where it is different from the book, because the book gives you formulas to memorize, and we want you to understand when you look at the equation how the transformation should occur based on the way we've done every other type of equation this whole entire year.
We're making it easier.
We are making it easier. So what you are going to do is, if you have a coefficient inside the parentheses, you are going to factor it out in front of the parentheses.
But inside the function.
But inside the function. So this is going to require you to do some division here, okay? So we're going to show you how that's done. We're going to describe the graph of this and then sketch the graph. Notice that before we start, we want to rewrite the equation. Notice that we have this 2 right here. So g of t is 3 cosine. Now we're going to bring the 2 in front of the parentheses, and the plus 4 is still hanging out there at the end. But if we take that 2 and divide it out, we have to divide it out of every term. So now that makes that t minus pi over 2. And always double check your work and redistribute in your head to make sure you did the right thing. And do you see that now once you have this, you have all the information you need. A is 3, B is 2, we'll deal with that in a minute, C is pi over 2, and D is 4. Now, this means
negative pi over 2. Or no, pi over 2. That's right, yeah.
So D means we're going to go up 4. C, where is pi over 2? It is to the right of 0, so we're going to shift right on that. B is 2. That means our period for this function is 2 pi over B. So our period is pi. So one cycle is going to happen in pi units. Again, remember, this tells you how many cycles in the standard 2 pi interval will occur. And our critical points are period divided by 4. So now that I have an A, a B, a C, and a D in the problem, this is the way I think about it. I do the easiest thing first, and that is the 4, and I look at what with the A. What's going to happen? I look at the last. I didn't write 4. The first thing I do is the 1 and this, because that is the first place you're going to make mistakes. Very often when you get around to doing the C with a shift, you have some issues after that. So I like to do the easiest thing first. The easiest is shift up 4 and recognize I've got to go 3 above and below that. So here's my 4. And now that I can see my 4, I'm going to go 3 below it and try to go about the same distance, 3 above it. Okay? And we're going to sketch in the line. And now it's better to be, when you have this, it's better to be a little more accurate. This isn't the best, but oh well. We're really interested in these points. Okay? All right, next thing is, so I've taken care of the vertical shift and the amplitude. Now we're going to do the horizontal shift. Now on this we have to shift to the right pi over 2, but we have to keep in mind with our shift how long we have to have our period. Okay? So I'm going to shift it pi over 2. I'm going to get 1 cycle in pi units, but I'm starting at pi over 2. But I don't have to, I can go all the way out to pi if I wish. I can go, in fact, this problem says go from pi to negative pi. So I'm going to put pi way down here, and I'm going to put negative pi way down here. Okay? And what do we know happens? Well, we would generally like to start marking off our little increments here, but you cannot do that when you have a horizontal shift. You have to deal with the shift first. And our shift is to pi over 2. Okay, so here's our shift, and we need to draw a clear translation of that axis. Probably don't need to put the arrows on it. Okay, so there's our shift, and we want to label that. That is at pi over 2. Now from this point, guys, from that point is where we start counting off our critical points. Okay, so I need to have a critical point every pi over 4 units from where we're starting. Okay.
So pi over 2 minus pi over 4 is pi over 4.
Okay. Yeah,
so
that would put me
pi over 4 is a critical point, which may not be true every time. Depends on what your shift is.
Mm-hmm. And then adding pi over 4 to that puts me at 3 pi over 4. I can do that addition now. And then I'm going to come over here and mark these off. I can tell by what happened over there what my scale is, and I can see that this is going to be negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. Now, there's one last thing that we do, and that is, let's look at the function. So the last thing I think about, well actually it's usually the first thing that I think about, is that I'm looking at cosine. Cosine starts at a max and goes down if our coefficient in front of it is positive. So I now know that over here, on this axis right here, I am at a maximum. So my maximum is happening at 7. Okay? Now, I need to go to the right, but I'm not going to get a very clear picture of one cycle by going to the right first. So I know that one cycle occurs in pi units. So I'm going to count off pi, a distance of pi, which is going to take me all the way over here at pi over 2. And that is the end of one cycle if I go backwards from where I started. Halfway in the middle is a minimum, and halfway between my maximum and my minimum have to be zeros. So there is one cycle right there. Now I can see what the rest of this should do. We can see that to get to a maximum, I had to come from a 0, and then from a minimum to that 0. And over here, my next thing has to be a 0, moving to a minimum from this maximum. So you can see that when we put all of the elements in the equation, it takes an awful long time to do a very good and clear graph. Notice also, one of the things we like to see, there's two things we really like to see when it's possible. We like to see 2 cycles, if possible, and we like to see both sides of the vertical axis. In other words, we like to see positive and negative. And if we remember, notice that cosine is an even function. And let's look at the cosine of pi over 2 of this function. If we just did pi over 2, I'm going to change that to g of pi over 2 is 7. And what happens at g of negative pi over 2? Cosine is an even function. If g of pi over 2 is 7, g of negative pi over 2 better be 7, and notice that it is. So you bring all of those elements to your graphs.
One thing I want to talk about before we leave this page is notice that our shift, our horizontal shift, was pi over 2. What would happen if it was pi over 3 and our critical points were pi over 4? Now I've got pi over 3 is where I start. Pi over 4 is my critical points. So now I need to have a common denominator in order to add these stinking things. So there is a whole other element of adding fractions that will be useful for you. So warm up on those fractions. Baby.
Yeah, and go back to middle school and remember, let's forget about the pi for a minute and just do 1/3 plus 1/4 and figure out what that is, and then stick the pi back in there to put it on the axes. There's one other thing, too. One of the things we mentioned in the last video was other ways to name the equation. So let's look at, because this is something you're going to be evaluated on. Again, another bonus for those of you that actually watched the video. Notice that this equation was started here. That was what this function defined. But what if I wanted to start here?
Well, now it's still a cosine function. Because it starts at a minimum and not at 0.
Oh, but it's starting at a minimum, so what does that mean?
It's negative.
Okay,
and we know that the amplitude is still the same, so the amplitude's still going to be negative, or the amplitude's still 3, so it's -3 cosine.
And I've already done the hard work of factoring that 2 out, so we're going to leave it factored out.
Yeah, but we don't need to shift it horizontally anymore, so that means it's just 2t, and then plus 4.
Yeah, even though it's starting at a 1, we still have the vertical the shift at 4 up. Okay, so let's do another one. Let's start this here. Okay, let's start at that point. Okay, go, Ms. Heller. Give me the equation.
So we'll call it f of t.
Oh yeah, you know what?
Let's just name it, or h of t.
Let me call this last one. That's good. Let's be more precise. Let's call the last one h of t. So let's call this
f of t.
F of t.
All right, so this is f of t. Since it starts at a 0, we're going to make it a sine. Okay, it's going in the correct direction. It's going 0 to maximum, so that means it's +3
Yay.
as the amplitude.
This doesn't change at all.
Yeah, because the, what's it called?
We still have the same period.
Oh yeah, the period's the same.
So much to think about.
All right, but we did do a horizontal shift, so it's going to be t minus pi over 4. Close parentheses. Then we're going to still add the 4 at the end because it's shifted up 4. That's not going to change regardless of which one we're doing.
So the things that don't change are this number
Period.
and this number and
the shift, the vertical shift,
and that.
the amplitude.
The plus minus can change. Let's do one more fun one. Let's see, we've done a negative cosine, a positive sign.
Let's do a negative sign.
Ooh, let's do this one. So we're going to do that one now.
Let's
okay?
call it y of t.
Oh, okay. That's confusing for children. Confusing. Hey, what function are we graphing if we start right here, peoples?
All right, well, it's a negative sign because we're going from a 0 to a minimum.
So I'm going to put my negative, I'm going to put my sign here, but what's my number in front of that?
The amplitude's still 3, so it's 3.
Mm-hmm.
The period is still 2.
Well,
Period
B is still 2. Yeah.
Okay, we've got t plus pi over 4, since it's shifted to the left pi over 4, and then still plus 4.
Okay, guys, here's an important thing for you to know. You're going to be asked to do this a lot, so make sure you understand how to take any given equation and write it in several different ways. Got it?
I think it's kind of fun.
It is. It's fun. We like it. We're nerds. Okay.
All right, go ahead and determine A, B, C, and D, how often the critical points occur, and then sketch the graph of this function.
And notice you're having to do all the whistles and bells.
All right.
And
so,
yes, I have a whistle somewhere.
Okay. So, to confirm that you have watched the video, email your teacher by 8 a.m. the day you have class with the following information: 1 new thing you learned, 1 good question, and 2 old skills that are important recall for this material. And don't forget to bring your entrance ticket to class.
There's my whistle.
Oh, goodness.
Love y'all.
Bye.